All right, we're back. We are back. Let's finish this. So in the previous example that we did, what is this? Okay, this is the previous example that we did. It's right here. I'm sure you can see the screen now. Okay. Yeah, okay. So this is, it says, this is the example we did, but that example have part A and part B. It's the same sample of 35 fifth graders that has a mean of 35, 82, and the standard deviation of 15. We did part A, we did part B. Part B says find the 95% confidence interval. We did that, and we got it as this, and we concluded that we can say with 95% confidence. Or actually, I forgot to put confidence. You can say with 95% confidence. I forgot that part. Confidence. So you can say with 95% confidence that the mean reading scores for all fifth graders is between 77.03 and 86.97. So now let's look at the other question of, I think this is part C. Part C of that question says to find the 99% confidence. Again, remember the sample mean. I will have everything here, and so I'm going to just copy it from here. Sample size is 35. Sample mean is this. Standard deviation is, so I'm going to have this right here. Oh, I'll put this right here. Here. So I'm going to put it right there for that place. So the sample mean is 82. Right there. Okay. Okay. All this. Sample size 35. Sample mean is 82. Okay. One more coming in. So 82. Now, standard deviation is 15. Now, this time they're looking for 99% confidence interval. So the critical value, which is the Z alpha over 2, you should get here. Z, I would say alpha over 2. Also, for 99%, that's the critical value. We have it here as 99%, we have it at 2.58. If you don't have it here, then you calculate it using the method I showed you in the previous lecture, P over 200, and then you find it on the table. But the good news is that we have it already. So 2.58. So I'm going to put it right there, 2.58, I think. Yeah, at 9% is 2.58. So I'll go over there and put 2.58. 2.58. Yeah. I'm going to adjust this a little bit. Okay. Now we have this. So now next thing is to calculate the error margin, the error. So I told you that the formula for error is this here. I'm going to copy it and then paste it there so we can calculate our error margin. So it's the same process, except that this time around we're using a different critical value, which is 2.58. Okay. Now, given that our sample mean is that our sample size is 35, so I'm going to write this down. N is 35, which you can see right here, 35. And sample mean, and standard deviation is 15. Delta is 15, and at the critical value is 2.58. Z alpha over 2 is 2.58. Now let us plug this in this formula. and then calculate our error margin. Yeah, calculate this. So I'm going to take you to the other workbook so that we can find our put this formula the right way. So I'm going to move all this. If you can see this, I'm sure you can. Good, excellent. So it'll be here. Oh, excuse me. So this time it is only this thing what will change, 2.58. 2.58 times 15, which is the standard deviation, and then sample size of n, which is 35. So I'll write it down, and then we can go to our calculator and get it. 2.58 times 15 over square root of 35. So we go to our calculator. I have to find it. It's right here. Okay, so all right, it's right here. So plugging this in, give us, I got 2.58. Okay, 2.58 times standard deviation of 15 divided by square root of 35. Okay. Now it was 6.54. Okay. 6.54. So we got 6.54. Okay, well, let's go and put it in the workbook. 6.54. And we can copy this all and paste it in our main workbook. So we use it. Okay. Hope you can see this. What I'm looking for here. Okay. I'm looking for the main workbook. I comprise account. Okay, I see, I got it. So we paste it here. Okay. 6.54. Now, we can now get our 95% confidence interval. Sorry, our 99% confidence interval as x bar minus error, less than mean, less than s bar plus error, which is basically telling you to put s bar is sample mean of 82. 82 minus error. Our error is 2.65. Okay. 2.65. So we've got it here, 2.65. So put the less than symbol. So I'm going to get it from here. Less than the mean. Less than. Excuse me. Less than the mean. Then less than. On the right side, we got x bar, which is also 82, plus error of 2.54, not 64, 2.54. 6.54, 6.54, not 6.54. So 6.54. So on the left side, you subtract it. On the right side, you add it. That'll give you the confidence interval. So I'll repeat, put this down, and then we get it from the calculator. Minus 6.54. Okay. So I'll go to the calculator, get our subtraction and addition. So clearing this, I have 82 minus 6.54. Okay, 0.54 is 75.46. Okay, then on the right side, you add it. So I change this to plus, so you can go just enter it. It's 8.54. 54. So now, let's go to our book and put these things in. Okay. It's our book right there. So for this, we repeat the same thing. So this time around, we have our box here. So we have our answers right here. Okay. Left side is 75.46. And the answer I got from the calculator. I'm going to move it down a little bit. Okay. So that we have the right side. That's what I got from the calculator was 88.54. So we can now conclude. Conclusion. Oh, 88, not 888. 88. So conclusion. So you can say, we can say, or we are, this time we're looking for 99% confidence now. So we are 99% confident that, now, according to the question is looking for trying to estimate the reading scores. The first one was 99. So the third one is 99. So you see the 99% confidence interval for the main reading score. So we can say we are 95% confident that the reading scores of all fifth graders, the mean reading scores of all fifth graders are or lies in the interval 75.46 to 88.54. This is an example of 35 for fifth graders. So this is basically what confidence interval for the means about. Okay. Here we use the same thing. We use 95% to get 77.03 and 86.97. Here we use 99% of the question to get this 75.46 and 88.54. That's what it is. So we have to find the confidence interval, find the critical value, find the error margin, subtract it on the left side, add it on the right side, you get the range of two values, and then you conclude. Question for me? The question, scholars?
Can you scroll up to the table, please? That has the most common.
Oh, this one?
Critical values.
This one?
Yes. Okay.
I'll take a photo of it. Yeah. Okay, got it?
Yes, thank you.
Welcome. Now, let us see. And the example I'm about to do now is the type you will see in your Excel assignment 4. The one that is due this week. In that case, they didn't give you the mean, they give you the list of numbers. And like this, and they say find the confidence interval for the mean. So that means you don't have the mean, you may not have the standard deviation, but they give you a list of numbers. They say find the confidence interval. So I want you to pay very close attention to this one, because that's what you're gonna see in the last Excel assignment you'll be doing, which is Excel assignment 4. See here, a random sample of the number of farms in thousands in various states are as follows. So, number of farms in various states. Excuse me. Now, say estimate the mean number of farms per state with 90% confidence. Assume that standard deviation is 31. So now, first thing you do is to put these numbers in Excel. Or if you like, you can use formula for finding the mean. I taught you how to find the mean at the beginning of this semester, where you add all numbers and then divide by the number of items you have on the list. Find the mean, find the standard deviation, then follow the same process that I explained before to find their confidence interval. So let's do it. Well, Excel will make it faster. And the way I'm doing it in Excel, it will help you to do your Excel assignment for. So let's do it. I've already entered these numbers in the Excel already. Okay, so let's see. I think you can see. Can you see my Excel screen?
Yes.
So I've already entered the numbers. So what you do now, Excel will calculate everything for you, and it will give you the error margin. So that error margin, you go and plug it in. So the first thing you do is to click on data. See? Then you have your data analysis tool right there. If it's not there, you have to put it by yourself. If you click on data and you don't see this data analysis, that means you have to add it. My own, I have already added it. So add it. Then once you click on data analysis, let me move this into the side. Okay. Click on that and choose what they called descriptive statistics. So you click on that, and then excuse me, I think I did this before, that's why it's showing this. Okay. So now you click on this here and go and highlight all this. So this one is not one. It took me somewhere else. Wow.
Professor, I have a question.
Yes, ma'am.
So on all the other Excels, you know how you give us like a little tutorial on how to do it? Like, does this Excel assignment also come with that as well? You know, like the steps?
Yeah, you come with that one too, yes.
Okay.
I'm just trying to actually do it so you can see. Yeah.
But it's just like all the other ones though, right?
Mm-hmm.
All right, thank you.
I like those numbers that I give to you that you have already entered here. Okay. Click on here. Then, since you don't have to, you not highlight the title here, so you don't have to check the levels. So no need to check the levels. Now for the output range means move me out of here again. Output range means where you want it to appear. It took me out again. And this is right here. So you highlight this. Oh, you know what? I shouldn't even do that. Output range means where you want it to appear. So I can click here. I can just click here. I want it to appear here. Okay. Now, I choose summary statistics. See, choose it. Then choose confidence interval. Now this question says 90, so I'm going to put 90 here. Okay. Now that's all you need to do. And you click OK. It will give you numbers, right? Everything. It will give you the mean, standard deviation, everything. Now, this is what we give. This is the confidence. This you can see when you scroll down, you see where you wrote confidence level. That is your error margin right there, which is 9.5. So 9.5. Let me write it down. 9.53. So now with this, you can have a question and then use the error margin to get your confidence level interval. Here, I have my error margin. Error is, got it from Excel as 9.53. So now I plug it in here. So you have the error, the confidence, the 90% confidence interval becomes push this down. Yeah, 90% confidence interval. 90% confidence interval is given by this. X bar minus error. I mean, what I mean from Excel. Let me write it down. We got our mean from Excel as this. This is given here. Right here. Mean is 43. So here. 43. X bar is 43.45. And standard deviation is given here as 31. 31 basically at 1.27. Okay. Now we don't even need it. You just need the mean. Only thing you need is the mean because they gave you the error margin right here. That's 9.53. So you just go to the formula and then put it in. Okay. Okay. Yep. So we put it in. Our mean is 43.45 minus error of 9.53 less than the mean. Less than samples of 43.45 plus the error of 9.53. So writing this down, 43.45 minus 9.53. I'm going to go to the calculator and I'll get the result I want. So you're going to be right here. Okay. So I'm going to move this up like this. So I have 43.45. Yeah, 0.45 minus 9.53. Okay. 53 give us 3.92, less than the mean, less than. And if you put this in here, if you add it for the upper side, give you 52.98. So we go in, I go there, you can go there and put it in, and then you get your confidence interval. Okay. Go and put it in. We have here we have subtract this. We got 3.92 less than the mean. I'm gonna copy from here. Less than the mean. Okay. Less than. If you add this with your calculator, you can get 52.98. So these are the this represents the number of farms in thousands in various states. So you can conclude that here. Conclusion. We can say with 90% confidence that each state on average between my 3.92 to 52.98. Any query? Any question? Any question to this? Scholars?
No, thanks.
So now, that is it. That is how you get confidence in power, not the for the mean. I mean, you get the confidence in power for the mean. That's what you're gonna do. So we have let us look at how to determine the minimum sample size to use. Minimum sample size to use. So you want to choose a sample size that will represent the population of interest. What is the minimum sample size to use? That case, we use this formula to calculate it. Minimum sample size. Okay. Now, let's try it. Basically, it says the formula is n equals z alpha over 2 times standard deviation over error squared. This is z alpha over 2 represents the critical value. Delta is for standard deviation, then E is for error. Then you square your answer. That's give you the minimum sample size to use. So let's do it. Here it says here that it is desired. Maybe one example will help us. So it is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? Assume that the standard deviation is this. So it's a to estimate the true mean number of chips per cookie within 2 chips. That means if you're going to make a mistake, you're going to affect only 2 chips. So you say estimated with 98% confidence. Solution. So for z alpha over 2, you say 90%, 98%. So z alpha over 2 will be alpha will be this, right? But 2 will be equal to 98%. I have a let me see if we have it in the critical value chart already. Right, 98%. Okay, we have it here as 2.33. 2.33. Yeah. 2.33. So we go down here and put 2.33. 2.33. Yeah. Now standard deviation. Let me adjust this a little bit. Okay. Now standard deviation is given us 10.1 chips. So I just copied it. 10.1 chips. I think I'm going to move this down. So I can have enough room. So you got 10.1 chips. Okay. Now error. It said to estimate the true mean number of chips per cookie within 2 chips. That means if you're going to have an error, it's going to affect only 2 chips. So our error is 2 chips. So to find the minimum sample size, the formula we use is that formula I just mentioned. So I'm going to put it in like this. Then we'll go and find it in the other workbook. Let me write these numbers down first. I got z alpha over 2 as 2.33 and delta as standard deviation as 10.1, error margin as 2. So plugging it into this formula, I'm gonna put this formula as well, so we can paste it in the main workbook. Okay. Yeah. So we have to square the error. So now that gives us equals. We have, I'm gonna put this first, then put the parentheses first. Second, I mean to say. Then I'm gonna put the fractions. So we have z alpha 2, we have it as 2.33 times 10.1. Standard deviation is 10.1. This one is 10.1. 10.1. But error is 2. That is square answer. It's a square. So we're gonna work this out. Write it down. 2.33 times 10.1 over 2 squared. You can bring our calculator. Okay. See. Can you hear me? Okay. Now let's have the calculator right here. Can you see the calculator, scholars?
Yes.
Excellent. So let's put these numbers in. Move this out. That is. We have 2.33. 2.33. Okay. 0.33 times 10.1. Yeah, 0.1 over standard deviation of 2. Okay. Then square it. 138. 138. 138.45. Now, always round up the next number. I know if you round it, you're gonna give you 138 because this 4 is not up to 5. 0.4 is not up to 5. But this time we're not doing that. We are going to the next whole number, which is 139 samples. So I'm gonna go to that book and put this in. 138.45, which means the 139. Make it a little bit smaller so you can accommodate this. Maybe 14 should we do. So copy this and go to our main workbook and paste it. Yep. Yeah. So we need 39 on we need 139 samples of all cookies. Any question? Any question on this?
No.
Okay. Now, in our next session, we complete the this number 7 and 8. You can try as a practice how to find the sample size. Next session that we look at confidence interval for the mean for the small sample, and that will be please log back in after 10 minutes so we can finish it up and then go home. Okay. So
You said for us to come back after 10 minutes.
Yeah, for the last session.
Okay.
So we can look at confidence interval for the mean for small samples. Okay, see you then. Okay.